Hello everyone, today topic is separable differential equation, in which we discuss about idea, strategy and take an examples. Okay, first we take a linear differential equation which is in first order. dy by dx is equal to f of x comma y. Here we take a f of x function is depend upon two variable. First is x and second is y. So we need to separate these two variables for further solution. So dy by dx is equal to g of x and into h of y. Here the function g of x is depend upon the x variable and the function h is depend upon y variables. Now for the solution of the first order differential equation, we need to separate the function of x is one side and the function of y is another side. So multiplying by dx in both sides, g of x into h of y into dx. Here the dx and dx is cancel out, so final dy by dx is equal to g of x and h of y into dx. Now if we move h of y from right side to left side in any way, then h of y is separate from g of x into dx. So if we multiply by 1 by h of y in both sides, h of y into dy is equal to 1 by h of y g of x and h of y into dx. Here h of y and h of y is cancel out, so equation becomes 1 by h of y dy is equal to g of x into dx. Here we got the function which is depend upon y is left side and the function which is depend upon x is right side. So we take a further step to integrate both sides. H of y and d of y is equal to integration g of x into dx. This is the strategy about the first order differential equation solutions, and we take an example to clarify this concept. Let's take an example to solve a first order differential equation. If we have dy by dx is equal to x plus x into y square. Now first in mind to separate the variable which is depend upon x from the variable which is depend upon y. So dy by dx is equal to, if we take a common x in both terms, 1 plus y square. Here the function of x is separate from a y variable, so now multiplying in both sides by dx, dy dx into dx is equal to x 1 plus y square into dx. Here dx and dx is cancel out, so final dy is equal to x into 1 plus y square into dx. Now if we multiply by 1 by 1 plus y square in both sides, so final is equal to 1 by 1 plus y square into x into 1 plus y square dx. Here 1 plus y square and 1 plus y square is cancel out, so equation becomes 1 by 1 plus y square dy is equal to x into dx. Here the function of y is left side and the function of x is right side. Now both variable is separate from each other, so the further step is integrating both sides. 1 by 1 plus y square into dy is equal to integration x into dx. As we know that the 1 by 1 plus y square, if we integrate 1 by 1 plus y square into dy, the integration becomes, and we got tan inverse 1 by y. So put this value in this equation, tan inverse y and if we integrate x with respect to dx, then we got x square by 2 plus we take some constant which is c. Here this is a general solution of this equation. If we simplify this equation for finding the y isolate from this equation, then multiplying by both sides isolate y from this equation, then we need to multiplying 10 both sides. So 10 into 10 inverse y is equal to 10 x square by 2 plus c. 10 and 10 inverse is cancel out, so y is equal to 10 x square by 2 plus c. This is a general solution of this equation, but this is also a general solution of this equation.